Alright, so this video we're going to look at error bounds for the trapezoidal and, well, the trapezoidal rule, but I also have the midpoint rule also. Well, let's just look at the trapezoidal. I'll have separate videos for the midpoint. Uh, so suppose f double prime of x, the absolute value, is less than or equal to k when when x is between a and b. And if the error for the trapezoidal rule, that's the errors in the trapezoidal rule, e sub t, the absolute value, is less than or equal to k times b minus a cubed over 12n squared. So the main thing that we're doing here, the more difficult part of the problem, is figuring out what k needs to be. Okay, so I've got 3 examples to work. Each example is going to have its own video. This will be the example 1, so this will be the first video. The second video will have cosine x squared, and in the third video we'll have, which will be example 3, we'll have e raised to the 1 over x. Okay, so let's go ahead and look at the examples. Alright, so let's look at the third example for the trapezoidal rule. So let's go ahead and write down the formula. Alright, so we've got absolute value e sub t less than or equal to k times b minus a cubed over 12n squared. So, well, we know a, we know b. Okay, that's the limits on our integral. We got to find k. Alright, we got to figure out what k is, and then we'll solve for n. Alright, so we need the second derivative of e raised to the 1 over x. Alright, so I've got f of x is equal to e raised to the 1 over x. And so the first derivative, f prime of x, well, that's just what? E to the 1 over x times the derivative of the exponent. Now, what's the derivative of 1 over x? Well, that's negative 1 over x squared. Okay, so how did we get that? Well, remember, 1 over x, we can write that as x to the negative 1. Then to find the derivative, we just use the power rule. So the negative 1 comes down, subtract 1 from the exponent. Okay, and then if we rewrite this and put the x to the negative 2 in denominator, that's negative 1. And then remember, when you move it to the denominator, it changes the sign of the exponent. Okay, so that's where that comes from. So there's the first derivative. Alright, so now I need to take the second derivative. And to take the second derivative, I'm going to rewrite this thing as negative x to the negative 2 e to the 1 over x. Just be easier to take the derivative. We'll have to use the product rule. Alright, so f double prime of x is equal to, so the product rule is the derivative of the first term, so the negative 2 comes down, so that's going to be 2x to the negative 3, okay, times the second function, e to the 1 over x, alright, plus the derivative of the second function, which is e to the 1 over x, alright, times the derivative of the exponent, so times negative 1 over x squared, times the first function. And I'm going to go ahead and rewrite the first function as in this form. Okay, so that's negative 1 over x squared. Alright, see this is the first function here. This is the first function. Instead of writing the first function like this, I wrote it like this. That's all. Okay. Alright, so now let's clean this up a little bit. That's going to be f double prime of x is equal to 2 over x cubed e to the 1 over x, and then a negative and a negative make a positive, so that's going to stay plus, and that's 1 over x squared e to the 1 over x. All right. And so let's do this. Let's write f double prime of x is equal to e to the 1 over x times 2 over x cubed plus, I'm sorry, this right here should be a 4, x to the 4th, plus 1 over x to the 4th. Okay. All right. So there's our second derivative. Now, we got to figure out what k is. All right. Sometimes that's usually the toughest part of the problem. A lot of the times is figuring out what k is. All right. So we know that we are on the interval 1 to 2. Okay. We're integrating from 1 to 2. All right. So what do we notice about f double prime of x is doing what? All right. So let's look at going on x values from 1 to 2. So one thing that I notice is the x values, okay? If my x values are getting larger and larger, okay, the denominators here are getting bigger and bigger. And when the denominators get bigger, the whole fractions get smaller and smaller. So that tells us that f double prime of x, as I'm going on this interval 1 to 2, it is decreasing. Okay, f double prime is decreasing. All right, so remember, we want to find the largest value possible. Okay, I need for k, because remember, k, my absolute value of my second derivative, has to be less than or equal to that. All right, well, the only way that's going to happen is if I let x equal 1 to find k. All right, so let's see what we get here. So I've got absolute value f double prime of x is equal to e to the 1 over x, okay, times 2 over x cubed plus 1 over x to the 4th. Okay, now if you notice here, I did not put absolute values here, did I? Well, I mean, I can, but I don't have to, because what values are x taking on? Well, they're taking on values from 1 to 2. Well, values from 1 to 2, this thing's going to always be positive, so I don't need to worry about the absolute value. All right, so I know that this on the interval from 1 to 2 is going to always be less than or equal to e to the 1 over 1 times 2 over 1 cubed plus 1 over 1 to the 4th. All right. So all I did is I took the 1 and plugged it in for x here. And this is going to give me 3e. So I know that the absolute value of f double prime is going to always be less than or equal to 3e. All right. So what do we have? We will take k to equal 3e. All right. So now we plug it into here. K is what? 3e. B is 2. A is 1. And we're going to solve for n. All right. So I'm going to get 3e times, and then I've got what? 1 to 2. So that's going to be 2 minus 1 cubed over 12n squared. And this needs to be less than or equal to what? 0.0001. So that's 0.0001. Alright, and now we solve. So the n squared, we move up here. The 0.0001 gets moved down here. So that's 3e. This is 1 over 12 times 0.0001 less than or equal to n squared. And so I get the square root of 3e over 12 times 0.0001 is less than or equal to n. And so n is greater than or equal to, and that gives me 82.4. Alright, so we will take n to be 83. And this is our answer. Alright, so I hope that helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.